Okay, so we're going to be looking tonight at module number 2. Module number 2 is all about vectors. Now, module 2, we're going to be doing this evening, and then finishing up probably the next time we get together with any questions and such that you may have. But we're then going to be moving on to velocity, which we need vectors for that. So this is a good entry into that. So you'll notice that we have a learning plan here. The learning plan has the chapter 3 PowerPoint presentation. So we're going to go back a chapter in our book to chapter number 3, and that's where we're going to be getting the information and kind of the process and such for doing the vector analysis that we're going to be looking at. Now, this is going to be chapter 3, and I just want to remind you that our PowerPoint will always be the guide through the chapter, because there's going to be more in the chapter than what we're going to be going over. And as I had said last time, we're going to be erring on the graphical method side of things as opposed to the analytical. So they're gonna have approaches in both ways, but we're gonna stick most often to that graphical method. So make sure that you use this PowerPoint presentation for what's going to be applicable for your homework as well as what you're responsible for. And then if I go back a level, you're going to notice that we also have an assignment number 2 here. So we'll be looking at this assignment number 2 after we get through the information in chapter 3. So what I encourage you all to do is to follow along with the PowerPoint presentation, but then also have your book open, because we will be referencing our book as we go along, especially for the different examples that are going to be reinforcing the concepts. So as we look at the beginning here of our chapter and we look at our second section, 3.2, it talks about scalar quantities and vector quantities. So as you've been in mechanical design, you have experienced both, and you probably already have an idea of what each one of those are. Now, I know the definitions are here, but in your own words, what is a vector quantity? What would you say is a vector quantity? Anyone? Anyone online? No one in the room wants to share. All right. So
it's a line with scale.
Yeah, well, we represent a vector with a line and we draw it to scale, and that line is also going to have an arrowhead, which is going to depict its direction. Okay.
Yeah, and direction.
Yeah, no, that's good. And so a vector is going to be a quantity that needs 2 things to fully define it. It's going to need magnitude, which like you said is going to be how long you're going to make it, the scale of that vector or that line. But then it's also going to have direction. So we're going to be adding an arrowhead and then possibly an angle if it's not something that's horizontal or vertical, if it's any one of the angles in between. Now, a scalar quantity is where we only need one thing to fully define it. So scalar quantities are going to be things like distance, like how long is something, 8 feet, how warm is it, 78 degrees, or how long did it take me to do a task, 50 minutes. Additionally, it can be when I look at my speedometer in my car and I wonder, how fast am I going? Okay, I'm sure the speed limit 70 miles per hour, but sometimes I might be looking at it and just, another moment, it might be something different. Okay. But that number is a scalar quantity. I'm just giving one thing. I'm just saying one thing, and it fully defines whatever I'm identifying. Now, a vector quantity is going to be something, like we said, has 2 of them. So when we look in terms of speed is the scalar quantity, but velocity is the vector quantity. And the velocity becomes a vector quantity when we look at, for instance, 50 miles per hour, but I add the direction, like going north in my car. Now, all of a sudden, I'm a velocity because of that added direction. Another vector quantity is going to be acceleration, we're going to find out. And so is like displacement, because displacement is not only distance, like how far I went, but in what direction did I go? Okay, so vector quantities are what we're going to be looking at here in chapter 3, and kind of first looking at adding them, determining what resultants are. That sounds probably familiar to you. We're going to be looking at subtracting vectors, and then also looking at vector equations where we have 2 sides of an equation. We have to figure out some unknowns. Okay. So graphical vector analysis is going to be drawing vectors to scale, as Adam had said earlier, And we have to make sure that we not only are interested in how long that line is going to be, but adding direction with a arrowhead and any angle that might be applicable. So if we look in our book at figure 3.1, which is at the bottom of the second column on page 43. Oopsie. There we go. Here we have our first representation of a vector. So in this case, it's going to be aligned with that arrowhead, familiar to us, and vectors always need the arrowhead, because if it doesn't have the arrowhead and it only has the angle in this case depicted, we don't know which way it's going. It's on that line of action, if you would, but we have to know if it's going up and to the right or down and to the left. So you don't forget your arrowhead. We are going to be always drawing them to scale. So we're going to be using AutoCAD to create our vector diagrams, because it's going to be the most accurate way that we can get our results. Okay. And yeah, so that's a vector itself. Now, as we go back, because we're going to be using AutoCAD, couple things we need to know how to do that aren't much different than when we were creating the diagrams for our kinematic diagrams in the earlier chapters. So, so for instance, we want to draw lines at specific lengths and at angles, sometimes using that rotate or that copy command, maybe the move command at times, inserting lines perpendicular to existing ones, extending lines, trimming lines, drawing arcs. Probably also, in addition to this list, looking at changing your colors or layers or line types in order to kind of get differentiation when needed. So, so kind of just those real fundamental, types of things when we talk about CAD skills. So, and you should have all that based on your experience and your place in the program. So let's look first at graphical vector addition. So adding vectors together to find a net result. So the method we're going to use here is going to be the tip to tail method. And this is when we're going to be adding 2 or more vectors together to find their net effect on a body. Okay. And when we say we want to find their net effect on the body, or we want to know what the effect is by adding or combining vectors, that means we want to know what the resultant is. Okay, what the resultant is. So what class does resultant, vectors, maybe even components, probably sounds familiar from? Statics. Yeah, you guys did a lot of that in statics. You dealt with a lot of vectors, you drew a lot of vectors. Forces were your vector value, or your vector that you wrote and identified with. So finding a resultant here should be review for you. You probably also saw it in physics. I'm assuming there too. Okay. So this won't be anything that's new. So a resultant, as we know, is the combined effect of, some vectors that are going to be, having an effect on a body. Now, when we find a resultant, many times one of the variables we're going to use for a resultant is going to be capital R. It's going to be equal to, and you'll notice that we have A plus B plus C, but we also have this greater than sign in back of the adding operator. And what that does is it signifies that this is not an algebraic equation. This says that this is a vector equation. Why does a vector equation have to be called out and it can't just be a regular positive value? Why would that be? Any ideas? They are. So if I would try to add their magnitude together, what would happen? It wouldn't work. The only way I could add them together algebraically is if they're along the same line of action. And that's why, remember when you guys did components, where you got everything in the Y direction, everything in the X direction. Now you could add things on those X and Y axes, because they did have the same line of action. You maybe had a plus or a minus, depending if it was up, down, left, or right. But if we have things going at all different angles, that doesn't work. That doesn't work. So we need the operator to be different. So this tells us that this is not an algebraic addition. This is a vector addition. But I can add my vectors in any order, and I'm going to end up with the same net effect, or the same resultant. So here you'll notice that R can equal A plus vectorially B plus vectorially C. Yeah. Or it can equal C plus vectorially B plus vectorially A, so a different order. And then again, a different order of B plus A plus C. So no matter which order that I actually add them in, I will still end up with the same resultant. So if you're comparing maybe your answers and seeing, what did you get for this one? Or how did you do that problem? If somebody approached it differently than you or in a different order, that doesn't mean that it's wrong. Okay. There isn't just one way to do it. You can or add them in any order and you'll end up with the same net effect. So let's look at example 3.5 in our book. Now, example 3.5 is going to be on page 49. So we're going to kind of page ahead and kind of skip over some things there. Okay. I'm going to zoom out. And this example is on page 49. And this is example problem 3.5. Okay. And what they want us to do here, it says they wanted us to graphically determine the combined effect. So that's like adding, okay, vectors A and B together. So what that means is we want to find the resultant. What is the combined effects? What is the net effect on the body that these two forces are going to have? Okay. Notice that we're given the magnitude of 59 inches per second for A, its direction going up and to the right at 30 degrees. And then we also are given magnitude for B, 30 inches per second, and its magnitude going up and to the left at 60 degrees. Okay, so we want to add these two together. Now, earlier on one of our slides, I said we were going to combine these or we're going to add these using the tip to tail method. So what I've done is I'm going to open up my AutoCAD. I've already got this example problem drawn as far as the vectors themselves, the individual vectors. And then I'll show you how you can add and subtract those using the tip to tail method. So I'm going to close this and then I'm going to open. There we go. Open. And here are my example 3.5. Okay. So right here, what I have is I've already drawn vector A at 30 degrees and vector B at 60 degrees. Now, I didn't add all the labels here because as we create our vector diagrams, we're going to find that they're going to get really cluttered if we put in all of that information. So minimally, you need your line drawn to scale at the right angle with a label of a letter, as we see here, A and or B. Okay. And then the rest is fine. So if I want to, when I want to start this, I'm actually going to go underneath here for a second. Okay. So on this piece of paper, what I'm going to do is we're going to draw R is equal to A plus B, and it's going to be A plus vectorially B. Now there's two ways that we can draw this. In the book, when you only have, for instance, a keyboard to put your operators in, you want to add that greater than symbol to the right of our operator, whether that's positive or negative, we're going to find out. Okay. But if you're writing it out, and you'll see me do this if we write it out, just with paper, you can also put that symbol above each one of the variables, calling it out as a vector. Then we know that we're not going to simply take the magnitude of each one of those values and just add them together like we normally would algebraically. Okay. So here is our vector equation. Now, a couple things here. A vector equation, just like any other equation, has an equal sign and it has a left and a right side. Okay. So when we look, and this is where we always want to start with any vectors, is because there are two quantities that we need to know. We want to kind of identify, okay, for each one of these vectors here, what do we know based on our illustration? Okay. So as we look at on the right-hand side of our equal sign, we've got our first vector, vector A. Do we know its magnitude? 59 inches per second. Yes. So I put a little check mark down below. Do I know its direction? Yeah, it's at 30 degrees. So I would say if I get two check marks, I've got both of my quantities identified. This is fully defined. Okay, fully defined. Okay. Then we have vector B. Do we know vector B's magnitude? Yep. Do we know its direction? Yes. So everything on the right-hand side of my equal sign, do you see that? I know everything about it. All right. What about on the left-hand side? Do I know the magnitude of my resultant? No. Do I know the direction of my resultant? No. Now, In an algebraic equation, how many unknowns could we have to solve? To be able to solve, how many unknowns could I have? If I had one, I was fine, right? But if I got a second one and I didn't have another equation with the same unknown, I was kind of in trouble, right? I couldn't go any further. So in a regular algebraic equation with scalar quantities that only need one thing to fully define them, I only can have one unknown, all right? But when I have a vector equation, I can have as many as two unknowns, okay? Because again, each one of these has two quantities to fully define it, okay? So in this case, even though I don't know the resultant here, and there's two parts of that resultant I don't know, I'm fine. I'm fine. But if I get any more than two unknowns, then I'm not okay. If I get a third, then I'm kind of done. Okay. All right. So as we look here, I'll show you the process that we're going to go through. Now, first of all, because we have our equal sign here, we're going to look at the side of the equation that we know the most about, and that's obviously the right-hand side. Okay. Now, the equal sign is going to be represented by the origin for our vector addition here. So I'm going to go back to AutoCAD and I'm going to start. I always have to have an origin for any of these vector additions that I'm going to do. Okay, any of these vector additions. So I'm going to just I'm going to shift this up. I'm going to pan this up a little bit, maybe zoom out a little bit, and I'm going to create a little origin down here. Now, let's see. Hold on. I'm going to put this, I think, down here. I'm probably going to move it around a little bit. So I'm going to be on my object line layer. I'm going to create a line, and I am simply going to put an origin here. And it doesn't have to be super perfect. All right. It just has to be like a crosshair showing me where I'm starting. If you don't have an origin, I do take points off. That sounds really ticky-tack, but it also it clues me in, and it will clue you in as well where I'm starting. It's also a representation of that equal sign in my equation. So when I'm on the right-hand side, the first vector I'm gonna put at my origin is gonna be A. Now I'm just gonna keep that one there, and I'm just gonna copy, and I'm gonna select that vector and its label. And I'm going to start with the tail, which is the non-arrowhead side, and I am going to place it at the intersection of my origin, not on the side, at the intersection. So make sure it goes right in the middle there. And then I'm going to hit enter, and my A is placed. Then on the end point, on the tip of A, I'm going to add the tail of B. So I'm going to copy B. I'm going to take the tail of B, and I'm going to put it on the tip and the very end point, okay, of A, right? Okay. And now I have B placed. So if I look back underneath my camera here, I've placed A plus vectorially B on the end point, okay? Now, I'm going to have to go over to the other side and then put my resultant in place, but I have to cross over and go back to my equal sign. So when I go back into AutoCAD, I'm going to start my resultant's tail at the origin, the equal sign, okay? And then its tip is going to go to the last point that I created on my right-hand side. Because remember, these two have to equal. They have the same net effect. So in essence, when I look at adding A plus B, I'm going to find that my resultant, now I did add an extra layer here for resultant, and I made it green just so it was easy to see. I'm going to start it here, and I'm going to end it at the end point of B. And then my arrowhead is going to go up where that point of B is. So I'm going to simply create my arrowhead like this. Now, I'm going to tell you, you don't have to put arrowheads on that are going to be closed leaders. You're going to spend so much time trying to get the leaders to be the right size in AutoCAD through the dimensions and scaling and the sizes. That's not the busy work I want you to work on for this, okay? So you'll notice how I put my arrowheads in place, just 2 lines. That's it, random. I mean, they look relatively okay, but they're not perfect either, okay? So you just have to know which direction they're going in. So that's my resultant. Now, the net effect is up and to the right for the 2 on the right-hand side, my A plus my B. So my net effect, my resultant should have that very same net effect. Now to get its magnitude and direction, I'm going to add my dimensions. So I'm going to go on my dimension or notes layer, whichever one. To me, they're pretty much the same. And then I'm going to do an aligned dimension. And I'm going to go to the endpoint of my resultant, to the other endpoint, and then perpendicular to it. And this is going to be about 66.2. And then if we look, that would be inches per second would be the units. Okay. For this assignment for the vectors, I'm not too worried about the units. I want you to get used to the construction. So I'm only interested in what is your number here. I have 4 decimals. As long as there's 2 decimals, I'm totally fine with that. Okay. And you're going to notice that in the assignment, I do have an answer key there for you. So try to make those match or make those nice and close. You should get the answers right on when you're using AutoCAD because it's a lot more accurate. Now that's the magnitude. Okay. Then we're going to put an angle in place to get the direction or fully find the direction. So I'm going to kind of pull this out away from a little bit. And I've got 57 degrees from like 0 origin. Now, when you have your angles, you need to dimension them from like 0 degrees, okay, or 90. I don't mind if you do them from a vertical, but do not dimension them from another vector, okay, because we want to go from a known axis, if you would, okay. So 57 degrees here. So if we go in the book and we compare with what they did on page 49, they have an illustration of what looks like the CAD that they did. You'll notice that on the left-hand side here is the origin, the A plus vectorially B, and then here is that resultant. Now they have it rounded to, 1 decimal place, if you would, to the 66, and then they have the 57 degrees. So our answers, came out accurate. Okay. Any question there on a vector addition? Familiar? Okay. Now, if you want me to, I'm happy to add these in another order, but you'll notice here, I'm not going to take the time to do it on our AutoCAD, but you'll notice that at that same origin, I've got B plus A. It's going to be equal to my resultant. Okay. So in each case, my resultant comes out to the very same number. Okay. Even if I add it in a different order. All right. Because they're going to have the same net effect no matter which order that we add them in. Okay. All right. So let's go back to our PowerPoint. So that's example 3.5. Let's look at our next example, 3.6. Okay. 3.6. So here on page 50, we're going to have a couple more vectors to deal with. Okay. I've got 4 vectors that I'm going to be dealing with here. Okay. So if I go to AutoCAD and I pull up, I have this one also already pre-drawn. I've got my A, B, C, and D. If we look underneath, you'll notice that for each one of these, we have magnitude, direction, magnitude, direction, magnitude, direction, magnitude, direction. So they want us to find what is the resultant of adding together those 4 vectors. So first things first, our vector equation, go on the other side here, our vector equation is going to be resultant is equal to A plus B plus C plus D. And then I would put either my symbol above or the greater than symbol in back of our operator. Okay. Now, these can be written in any order. Remember, so if you want to do B, C, D, and then A, totally fine. Or if you wanted to do D, C, B, A, whatever. Okay. Any order here will get you the same resultant. So all you're doing is looking at the final answer and making sure that you get it. So in this case, I'm just going to add them in alphabetical order. So if we go back to our AutoCAD, we again are going to start with our origin. So for the problems you're going to be doing for me that are similar to this, you need to start with an origin first. So I'm going to start, let's kind of draw it over here. Vertical line first, and then horizontal line. And then all we're going to do is I'm going to copy A down, and I'm going to take its tail and I'm going to put it at the intersection of my origin. Then I'm going to copy. Oh, it looks like I'm going to have to move this because B is going to go over the top. So let me move this down a little bit. Okay. I'm gonna copy B, and I'm going to take its tail and put it at the tip of A. Okay, so this is A plus B. Then I'm going to do the same thing for C. I'm going to copy C, and I'm going to grab its tail, and I'm going to put it at the tip of B. So make sure that you have your object snaps on. Okay, so I'm just doing endpoints in this case for each one. And then I'm going to copy D, and I'm going to put its tail at the tip of C. So now that I have A plus B plus C plus D, I'm ready to go back to the origin and draw my resultant in place. So I'm going to take a line, go to that intersection, and go to the endpoint or the last arrowhead of my last vector. Okay. And then I'm going to add my arrowheads here. The tail is always going to start at the origin, and it's going to point to the last vector that I created. So I'm going to grab a line, endpoint. Here's the arrowhead. I always kind of make my resultant's arrowhead a little bit bigger. And then I'm going to grab the notes or dimension, whichever. I'll do my angle first since that's up right now. So here is my angle, but it's super small. So we're going to be doing screen snips for you, handing these in just like we have in the past. So you're going to want to go around this area, but they have to be, the dimensions have to be large enough so that I can see them on your screen snips. Okay. So to do so, you're going to have to go into annotate, and right down here in the dimension area, you're going to click on the down arrow. And you're going to probably be on standard, which is fine. Modify, and you want to go to the fit tab. And then you want to set this from 1. This is a scale of 1 for the text height. And it's pretty small. I'm gonna change it to 10. I'm gonna see how big or small that gets. I don't know how it's gonna work. I'm gonna set as current. I'm gonna close. Got pretty big. Probably could be 8 maybe on that one. All right. But that's how you can change the text size so that you can see it. And then you're also going to add, go back, an aligned dimension along the length of your resultant. And that's going to be here. Okay. I don't care about decimal places. If you use that standard format or the template, it's probably going to be 4. And again, that's not the focus. The way the dimensions look, I just have to be able to see the numbers. That's all I care about. But if you wanted to change the decimals, I know somebody may ask, I'm going to go to annotate, go back to that manager, and you can modify here. And the primary units tab, you can change this to however many decimals you want. Okay. And so if I change it to 2, for instance, and I say, okay, don't forget to set as current and then close. And then anything that is on that same standard dimension style will change to 2 decimal places, as you can see here. Okay. So you don't have to go to that length, but if you wanted to, it's there. So this is then what you would put, or what you would take the screen snip of and add to the assignment. Okay. Oh, one more thing. You do need to, and I'll copy this over, just make sure that you label your resultants. Okay. So you want to label your resultant and then find the magnitude of it. You don't have to add units. That's just, again, another step. I want you to just get used to maneuvering these around and making sure that you can get the right dimensions, and then also putting the arrowheads on and such. Any questions? So vector additions, piece of cake, review. Awesome. Okay. That's where I want you to be. So if you were bored for the last 34 minutes, that's good. Okay. That means that you've had this before. If you weren't bored, that's okay. And it probably was review. So, because I know you've seen it other places. Let's go back to our book and look at our next section. Vector subtraction. How many have done vector subtraction already? Done a little bit of that? Yeah. Okay, probably in math class, okay, but maybe not as much as vector addition. Vector addition is like the one that's in a couple places. How about online? Have you guys done vector subtraction before? Yeah. Okay. So so vector subtraction is going to be very similar, except all we have to do is we have to switch whichever vector we want to subtract 180 degrees and then just add what we call the negative version of that particular vector. Okay. So when we subtract a vector, we're going to reverse its direction 180 degrees. We'll see how we do that in just a bit. But when we look here, it's really the very same thing that we do in algebra. So for instance, if we say our resultant is going to be equal to A minus vectorially B, it really means that we're going to add the negative version of B, just like we do in algebra. We say we add the negative value, right? Or we just subtract that value. Either one gets us the same result, okay? So here, we're going to formally add the negative value. So instead of looking at figure 321, I want to go right to example 310. So in our book, we're going to skip forward a little bit. And at the bottom of page 55 is where we're going to find the example dealing with vector subtraction, okay? So it says graphically determine the result of subtracting the velocity vector B from A. So this time our resultant is going to be signified as J, and our equation on the other side is going to be equal to A minus vectorially B, minus vectorially B. So what we're seeing down here is going to be the fully defined vectors A in their positive direction and B in its positive direction. But we need to subtract off B. You see that? So what we're going to do is we're going to find the negative value of B. And it's super easy. All we do is we change the direction 180 degrees, and that's it, okay? So the negative value of B is going to go up and to the right. Its arrowhead is going to go up. Positive is in this direction. And we're going to call it negative B. That's it. That's it. So we would draw the positive value and then we just switch the arrowhead to the other side. Now, when we do this, it makes it really easy because now we're simply going to add the negative value. So if we're adding vectors, we're using the tip to tail method, just like we did for addition, except now we're going to use this orientation of B with the call out of negative B for it. Okay. So let's go to AutoCAD and we are going to open up example 310 this time. Okay. All right. So I've got my two vectors in place here and I want to find the resultant J this time. And it's going to be equal to A minus B. So this is the positive direction of B. So I'm going to copy next to it that same thing. Okay. And all I'm going to do to get the negative is I'm going to get rid of the two lines for my arrowheads, and I'm going to add in on the opposite side. Oopsie, thought I had it on the opposite side, 1 and 2. And then I'm going to change, double click on here, and I'm going to add a negative in front of my B. Okay, that's it. Now I have a negative value.
We're turning this. Do you want us to have the two separate cards?
Sure. Like you can just show this one. That's fine. Is that what you're asking?
Well, no, I'm asking like if you want to have like A, B, and then the actual like drawing of them together. Or if you can just do the drawing.
Oh, yeah, the final drawing is fine.
Okay.
The final is drawing. I'm just starting them here because then I can show you how I manipulate them. So, so what I believe you're asking is, so I'm going to, but always have your origin. So you're going to have to add that, and make sure that that is vertical, horizontal. And then now that I have my negative here, so I always copy because this is my start file for my next class. So you don't have to do a copy. You can just simply move them or start them at their origin right away. And then I'm going to copy. I'm going to put mine down here at the intersection. And then I'm going to move this one just because it's the new move there. And I'm going to put it at its endpoint. Okay. And then I'm going to add my resultant here. This one is called J. So make sure you get the right call out. So it's going to be line from my origin. Turn my ortho off. There we go. Okay. And then be sure that you put your labels, move them so that they're not overlapping and such. So you have a nice, decent looking sketch here. And then I'm going to add my J call out and change this to J. And I'm going to add my arrowheads. Again, crude arrowheads, not anything extravagant, but we need to know which direction they're going in. Don't forget them. And then finally, my align dimension for the length. Okay. And my angle from here to here and there. Okay. And then your question, you know, what do you want handed in? Did you want the originals and then this? No, just this final one is perfectly good. So I would do my Windows Shift S, or well, I'll get my cursor out of there. Windows Shift S, and then just around this is all that I want. That's it. Okay. You don't have to show the originals. Yeah. Okay. Any other questions? It's good. All right. Make sure though, when we're doing the vector subtraction, you're still adding tip to tail. You're adding the negative value. So this has to be called out as a negative B, and its direction is switched from its positive version. Okay. All right. Fun. I bet you can't wait to start this. You're like excited. I can tell. I can see it in your faces. Maybe not. Not online. You guys look like you're not very happy. You're neutral. I don't think you're mad or sad. You're just neutral about it right now. But it's going to get better. I promise. Because now we get to subtract more than 2 vectors. So this is a big deal. This is a really big deal. So we're going to turn the page and we're going to look at example problem 11. Okay. So example problem 11. Okay. Moving right along here. So on page 56, down at the bottom, we are going to find J is going to be like our resultant. It's going to be equal to A minus B minus C plus D. Okay. So now we've got 2 negatives here, B and C. I know you can't even handle the excitement here. This is good. So we're going to go over to CAD. I am going to open up my example 11 vector subtraction, and I'm showing these in the original positive directions. So the 2 that need to be negative are B and C. So I'm simply going to copy B down and C down. I'm going to copy C, actually over. There we go. And I'm going to change their call out to a negative B, negative C. And then I'm simply going to erase the original arrowheads, and I'm going to add new ones to the opposite side. So here too. There we go. Okay. And then instead of picking the positive values, I'm now going to pick those negative values. So it was A minus B minus C plus D. Okay. So I've got them all in the appropriate orientation. I'm going to start with my origin, which I'll put like right here. And I'm going to start with copy A. Isn't that command? Start at my tail, take my ortho back off, and I'm going to put it at the intersection of my origin. Now I'm going to move my negative value of B, tail. I'm going to add the negative value. So the tail of B is going to go at the tip of A. Okay, just like we did. And that's the reason I like this method. You're going to notice that the book, if you read the book, how many read the book? Do you guys read the book? Do you like the book? Oh, you were noticing?
Yeah, we're like,
They do a tip to tip. And that is a valid method, but isn't it a little confusing to look at?
yeah.
Yeah, I know. What I like about switching the direction, labeling it the negative value, but now I'm still doing my tip to tail, and I keep that process the same. The tip to tip it's not wrong, but it's hard to look at, right? Especially at this point. So what Jesse, right, is referring to is, if you look in the book here and you look at how they do their vectors, actually we can look, we can look over here at the current one that we're on. Here's our origin A, or our origin, and then we have A, right? That was a positive, but then B was a negative, and they're actually going tip to tip rather than doing the direction flipped and then tip to tail. And then they're doing the same thing with C. This is coming back down in the positive direction, but it would be where, if you would, the tip of B would have been. And then they're taking the tail of D and putting it on the tail of C. I think that's confusing. Okay. Instead, and I'm not saying my way is better than theirs. It's just another way. It's just another way. But to me, it's consistent with adding the negative value. So what we did was we changed the direction of B and C, and you're going to find we get the very same answer. So just this way. So yeah, I'm glad you saw that already. Let me get my vectors in place here. So now I'm adding the negative B, right? So it's still tip to tail. Now I'm going to do the same thing for C. I'm going to move the negative C version, and the tail of C is going to go at the tip of B. Okay. And then now my positive D is going to go at the tip of the negative C. So I'm going to copy this one. Tail to tip. Okay. So if you look at the one in the book, we're ending up at the same place, exact same place, except I think ours is easier to understand. I do. At least at this stage in the game, right? When you're just kind of learning it. And I'm going to start back at my origin, go to the last vector, and then I'm going to put my arrowheads on like this, like that. And then I'm going to move D so it's closer to that line. I would call this J, right? So I'm going to copy this over and rename this J. And then I'm going to add my dimension and my angle. So line dimension, and we should get 365. Look at that. Yep. Now I do need to make this bigger. So again, I'm going to go into my annotate, dimension manager, modify, and I'm going to go to the fit tab, and I'm going to say 5. Let's see how that looks. Set as current, close. Pretty good. Doesn't have to be perfectly all the same size like you did in tech drafting. Okay. And then I just need to add my angle. From the 0 degrees here, and I'll add it out here a little bit. There we go. Okay. So 81 degrees. Yep. And 365. So our method is a little bit different than what they do. So if you do look in the book, just remember their negatives would be the opposite direction, and then it's tip to tail. That's what I like about it. Any questions? So you can pick either way, okay, if you want to, but again, I think this way is a little bit easier. Okay. All right, so that's subtraction of a couple. Let's catch ourselves up in our book. Okay, so now we're going to be looking at vector equations, okay? It's really the kind of the last section here in the chapter that we're going to be looking at for chapter 3. So vector equations are when we have more than one vector on either side, and it's not necessarily looking for a resultant or the net effect of. Sometimes it might be trying to find a magnitude or a direction of a certain quantity. Now, when we rearrange vectors in an equation, the same rules of algebra apply. So for instance, you're going to notice that I have this written first as A plus B minus C is equal to D. Now you'll notice that we have a negative value for C there. And we can move any one of these quantities to the other side of the equation and use the same rules as we do in algebra. So if we have, you know, a positive or a negative value or adding or subtracting on one side, when we want to move it to the other side, we always do the opposite, right? So for instance, if I want to get C on the other side by D, I would add C to both sides, right? So you'll notice I can rearrange this and have A plus B is equal to D plus C, okay? So, so that still applies. And sometimes, yeah, I don't know, again, for those reasons that we just looked at, sometimes it's nice to eliminate a negative value so it's positive and a little bit more straightforward to deal with, okay? Now, sometimes we want to determine magnitudes of vectors that are unknown. So there are two example problems that we're going to be doing here. And we're going to be using two equations to determine two unknown magnitudes, okay? So let's look at example 316 and 317. And these are going to mimic, if you would, the last two problems that I have assigned for you. So we're going to move forward. And we're going to go all the way to page 63 in your book. Now, again, anything that we're skipping over in the book, you are not responsible for, okay? And you won't have anything, you know, like homework wise that'll be dealing with those items. So on page 63 here, we have equation or example problem 316. And at the top here, you're going to notice that it says the directions of vectors A, B, C, and E are known. Okay, scooch over here a little bit. There we go. So vector A, B, C, and D are known. So here we have A. Now, in this case, we do have a known factor, a known quantity for A, but it's only the direction. We don't know its extents, whether it's going left or right, or how long that vector is. Okay, so we know direction only. Additionally, you're going to notice that very same thing for E. So in this problem, what we need to do is we need to find the magnitudes of vectors A and E, okay, knowing their direction. Now, let's see how the vector equation is called out. So right now, our vector equation is A plus vectorially B plus vectorially C is equal to D plus E. So I'm going to go underneath here. And we're going to look at, I'm going to make it a little bit bigger, A plus vectorially B plus vectorially C equal to D plus vectorially E. Okay. Now, as we look here, we want to identify what we know for each one. So for A, magnitude direction. So do we know the magnitude of A? No, but we do know direction, right? Do we know direction and magnitude for B? Yes, we know it for C. We know both for D, but here again, we don't know magnitude, but we do know direction for E. So number one, the good news is we only have two unknowns, okay? And that's as many as we can have in a vector equation. The other thing that's good is that right now, the way it's arranged, we have one of each unknown on either side of the equation. Okay, on either side of the equation, which makes it a little easier for us too. But what I do want to do is change the arrangement on the left-hand side. I want to get A out of the front of the equation. Why do I want to do that? Yeah, I don't want to start with, I don't know how long that vector is going to be. So if I start at an origin with A and I just know its line of action, I don't know where to put then the tail of B, right? So what I want to do is I just want to change this so that my vector that I don't know the quantity of is at the end of the string. So we're going to change the order here to be B plus C plus A. It's still on the same side, so we still add it. Doesn't change the sign. It's going to be equal to D plus E. And I'm just going to put my signs above. That's okay. So remember, even though I'm changing the order here, it doesn't change the effect of that side. Okay. All right. But now I'm going to start with known quantities and I leave my unknown at the end of the string. Okay. So this is going to be the order that we're going to use. So B plus C plus A is equal to D plus E. I'm going to go back to AutoCAD and I'm going to pull up my example 316. Okay. All right. So here I have, what we see in that problem that we just looked at. All right. There are no negatives here, so we don't have to worry about changing any directions. Okay. So these are going to be straight adding up. So we're going to start with an origin. Okay. So I am going to go to my object line layer line, and I'm just going to add my. Okay, there's my origin. Always start with an origin. And we're going to copy, just because I want to keep my original. You can just move, or you can just draw them in place if you want to. It's totally up to you. Move. No, I want to copy. Sorry, copy. And I'm going to take the tail of B and put it at the intersection of my origin. Turn the ortho off. Then I'm going to do the same thing here. I'm going to copy again. I'm going to do C, and I'm going to take its tail and put it at the tip of B. Okay. And now I've got my A yet. So I'm going to take A, I'm going to copy it. And instead of grabbing one of the endpoints, because I don't know if it's going to go left or right of the tip of C, I am going to instead do Shift right mouse button. And I'm going to do nearest on A here, right about there. And I'm going to put it on the tip of C. That's it. Okay. Or you can just draw a line, infinite, a construction line if you wanted to, at the tip of C. Okay. Now, if we look back underneath, I've done everything on my left-hand side of my equation as far as I can go. So now I'm going to go back to my equal sign and I'm going to place D. So the tail of D is going to go back at my origin. And then I'm going to add E on that side. Okay, so here's my D. I'm going to copy D. Tail is going to go to the intersection of our origin. Okay, right there. Oops, did I not grab? I didn't grab the. And then now I want to do the same thing as I did for A to E. So I'm going to copy E, and I'm going to do nearest. Okay, and I'm going to put it at the end point of D. I'm going to move my E to the opposite side here. Okay, so now what we want to do is we want to find where those two intersect. Okay, so you're going to notice that A, if I extend it horizontally, right? And I want to put my ortho on so it stays horizontal. Okay, I'm just going to grab my grips and I'm going to extend that. I'm going to do the same thing to E. Grab the grips and I'm going to extend it up over the top. There's the intersection for me. Okay, so now let's look back at our equation. We know that for A, we're adding it to C. So that means the tail of A has to start at the end point of C. And then the tip is going to go where that intersection was. So I'm going to go back to AutoCAD, object line. I'm going to go line, and then we're going to go from the tip of C to this intersection. Okay. And I am going to put my arrowhead, I could turn my ortho off. My arrowhead for A is going to go right here. Do you see that? Because I'm adding A to C. So I'm going to move this up here. Okay. And now I'm going to do that same thing for E. D plus E. So here, the tail of E is going to start at the tip of D, and it's going to go to the tip of A, or the intersection of those two lines. And then the tip is going to be right here for E. Okay. So now the only thing we need to do is measure the magnitude of each one of those. So since these are vertical, we can just do a linear dimension. Okay. And then I'm going to do the same thing here right away, and I will make it larger in just a second. So I'm going to go to annotate, Dimension Manager, modify, go to the Fit tab, and we'll do 5 again. Okay. Set current, and then close. There we go. All right, and if we compare our values to this example, you're gonna turn the page. You'll notice that E is 306 and A is 160. So we're really close. It's really odd. I don't know exactly where their rounding is, but I know that our numbers are good because I double checked our each one of the variables. So it's really pretty darn close, but I would call it good. I'm pretty sure ours is, I know ours is right. I know it is. Okay, so any questions? And then the part that you would hand in here would be the screen snip of just the final. All right, you want to do one more example or you feel good? Who wants to do one more example? Nobody. I'm good. I mean, I feel confident. You guys get it? Okay, you want to jump in and start working? I think you do too. I'm not worried, okay? The very last example is one more example, and you can kind of follow what they did, but it's the very same thing that we looked at right now, where we're going to have 2 quantities that you just need to find the magnitudes for, knowing the directions, okay? So then that's going to take us to the end of our PowerPoint presentation. Okay, so that means that's all the content in chapter 3 that we're going to be working on that's going to apply to our homework. So what I'm going to do here is I'm going to stop this video and then we're going to start a new one for the homework overview. So we'll look at the homework shortly.